Mr. Smith. Welcome to Algebra 2, Section 13.1. This is our last chapter, and we are talking about trigonometry. Now, most students in my high school should have seen today's lesson from their knowledge in geometry. Right? We've studied trig a little bit. However, we're going to introduce a few new things. So number one, we're going to introduce three other basic trig functions, and they are cosecant, secant, and cotangent. And I'll explain how they're related to our original three functions in a moment. Please recall there's a few basic pieces of knowledge that you should remember. SOHCAHTOA is one. Right? So SOH, that tells us sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We'll also need this idea of Pythagorean theorem, a squared plus b squared equals c squared. And lastly, we need the fact that the angles of a triangle all add up to 180 degrees. Those three pieces of knowledge are going to be very, very useful for us as we proceed. So, like I said, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And we also define cosecant. This is cosecant, secant, and cotangent. And the way these work is sine and cosecant are related. So sine is opposite over hypotenuse, and cosecant is just the reciprocal of that hypotenuse over opposite. And the same is true for these three new functions, cosecant, secant, and cotangent. Notice that sine goes with cosecant, cosine goes with secant. It's kind of backwards from the way that it seems like it should be, and that's actually how I remember it. One other thing to note here is this symbol, this guy right here that kind of looks like a 0 or an O, it is actually a Greek letter, and it is the letter theta. Theta. And it is just like in algebra when we use an x as an unknown. In trigonometry, we use theta for an unknown angle. Okay, so that's what that representation is. All right, so here we have a question where we want to evaluate the six trigonometric functions of this angle theta. So here's theta. And to find the length of the hypotenuse, I use Pythagorean theorem. So 5 squared plus 12 squared equals, we'll call this x squared. And if we solve this, we'll find out x equals 13. This is a Pythagorean triple. You should remember it. And so now sine of theta is opposite over hypotenuse. So opposite, 12 over hypotenuse, 13. Cosine theta equals adjacent over hypotenuse. So 5 over 13. And tangent of theta equals opposite over adjacent. So 12 over 5. Okay, so those are our basic three trig functions. Now we have cosecant of theta, which is going to be the reciprocal of sine, so 13/12. We have secant of theta, which is the reciprocal of cosine, which is 13/5. And lastly, we have cotangent of theta, which is the reciprocal of tangent, and that's 5/12. Okay, and those are our six basic trig functions. One thing to note, sine and cosecant are not inverses of each other. We use the term inverses later, and we'll show you how we do that. Okay. So here, if theta is an acute angle of a right triangle, so here's a right triangle, and here's theta, and I know that sine of theta is 4/7. What's tangent? Well, if sine of theta is 4/7, that means the opposite side is length 4. The hypotenuse length is 7. And to be able to tell what tangent is, I need to know the side length A. So, to find A, I use Pythagorean theorem. So a squared plus 4 squared equals 7 squared. So this is 49 minus 16. A squared equals 33. So A equals the square root of 33. So tangent of theta is opposite over adjacent, so 4 over the square root of 33, which when we rationalize the denominator, remember we're not allowed to square root in the bottom, so we multiply by square root of 33 over square root of 33. This gives us 4 radical 33 over 33, which is choice B. Okay, so these are some basic trig problems that would be similar to ones we should have seen previously. So now we're introducing our two special triangles, 45, 45, 90, 30, 60, 90. And the 45, 45, 90 is nice because these two lengths are always the same. It's isosceles. And so it actually allows us to use Pythagorean theorem here, if we want, where x squared plus x squared equals the hypotenuse squared. But the 30, 60, 90 we just have to memorize. And the way we do is we look at the short side. The short side gets multiplied by 2 to give us the length of the hypotenuse. And the short side gets multiplied by radical 3 to give us the length of the long side. And then, of course, we can talk about our trig values here. And these are always going to be true. So, for instance, sine of 30 degrees will always be 1/2. Sine of 45 degrees will always be square root of 2 over 2. Cosine of 45 degrees will always be square root of 2 over 2. Cosine of 60 degrees will always be 1/2. These are values that you will eventually want to memorize because we're going to use them over and over and over again. Okay. But at this point, you don't have to memorize them, but you'll see them over and over again. So here we have a special triangle. It's our 30, 60, 90. And they tell us the length of the hypotenuse. So that's 60. That angle's 60. The length of the hypotenuse is 8. So the short side length must be half of that, which is 4. And now to get the length of the long side, which is what they wanted, we multiply this guy, 4, by radical 3. And so in this case, we get a length of 4 radical 3. All right, so now they ask us to solve a triangle, to solve triangle ABC. And what that means is we want to find all of the angle values. So angles are always using a capital letter, capital A, B, and C. And sides, we always use a lowercase a lowercase b, and a lowercase c. And the angles and the sides correspond. So if this is angle A, then side A is the one across from it, or opposite from it. If this is angle C, then side C is the one across from it. If this is angle B, then side B is the one across from it. And we will use this type of notation from here on. Anytime we're talking about triangles, we'll try to use this type of notation. So I know angle A is 28 degrees. I know angle C is 90 degrees. I know side B is 15 units long. And now when they say solve, they want us to identify the other unknown values. And so every time you're solving a triangle, you should write out ABC, ABC, and then we should try to write all 6 values. So the easiest one to come up with from here is B. What's angle B's measurement going to be? It should be 62 degrees because all of these angles have to add up to 180. Easy enough to find. And now we want to find side length A. So let's talk about our reference angle being angle A. This will be our reference angle. And so if I want to find side A, I need to use tangent because tangent is opposite over adjacent, right? If I were to use something like, if I wanted to find A and I was going to use sine, well, it'd be A over C, but I don't know either A or C, so I don't want to use sine. Okay, so we have to pick the right trig function based on the information that we have. So tangent of 28 should be opposite, which is side A, which is what I want to find, over adjacent, which is side B, which length is 15. Okay. So to find A, we just solve this equation. This is a linear equation. Multiply both sides by 15, and A equals 15 times tangent of 28. And when we evaluate that, side length A comes out to be 7.98. Let's just call it 7.9. Okay. So up here, I can write 7.9. And to find side C, again, I'm using my reference angle of 28. And I know B is 15, and I want to find C, so I'm going to use cosine. All right, so cosine of 28 equals 15 over C. This is actually a rational equation because the variable's in the bottom, but it's still not too hard to solve. We're going to multiply both sides by C, divide both sides by cosine of 28, and we get C equals 15 over cosine of 28. Okay. And when we evaluate that, making sure that our calculators are in degree mode, we get a value of 17. A value of 17. Okay. And so now We've identified all 6 values for the triangle, and we can say that it is solved. All right, so what's nice about this section is that it lends itself well to word problems. If you were to see a word problem on a quiz, my bet would be that it would come from this section. So here we have a student trying to measure the height of a school. And the problem tells us we are 25 feet away from the school. And we measure up here to the height, and we get a 62-degree angle of elevation. Angle of elevation means, as I'm looking horizontally, and then as I look up, right, that gives us an angle of elevation. So 62 degrees, and we want to know the height of the school. We can call this height x. So the question is, what trig function do we use? What trig function to use? So I know this side, the opposite side. I know the adjacent side. So that sounds like we better use tangent. Tangent's opposite over adjacent. So tangent of 62 is opposite x over adjacent 25. So solve this, x equals tangent of 62 times 25. And notice it's not tangent of 62 times 25 altogether. It's tangent of 62. Get that value, whatever that number is, then multiply that by 25. Okay? And that should get us a number. So for all of my students in the class, why don't you evaluate that now in your calculators, and we'll get this value, and we'll move on to the next problem. If you're at home, please also calculate this. All right, so you should have gotten 47 based on what one of my students said. I take it, 47. So the height of school is 47, and I guess we're in feet, so this would be in feet. All right, one last question. So we have a kite. It makes an angle of 59 degrees with the ground. I don't know how you would know that, but okay. All right, so, and its string is 40 feet. Now that's easy to know. So we have our kite. It's blowing in the wind. It's pretty. Let's make it colorful. It's been a long time since I've flown a kite. I hope they still look kind of like that. Back when I was a boy, that's how kites looked. Anyways, the length of the string is 40 feet, and the angle with the ground, so here's our ground, is 59 degrees. And we want to know how high off the ground is this actually. Okay, so this is our x value. And again, the question we have to ask is, what trig function do I use? And the way that you can know the answer to that is, well, what side lengths do you have to use, right? So if this is my reference angle, 59 degrees down here, I know this side over here is my variable. It's my opposite side, x. This is my hypotenuse, 40. So what trig function uses opposite and hypotenuse? Must be sine. And so now we proceed. Sine of 59. Yeah, sine of 59 equals opposite over hypotenuse, x over 40. To solve for x, we multiply by 40. 40 sine of 59 equals x. Again, we use our calculators here, and we find out that the length of x is, what do you guys have? Go ahead. 34? Is that the consensus? Take your word for it. Seems reasonable. So our height of the kite is 34 feet. Okay? As long as that's what 40 times sine of 59 equals. And this concludes section 13.1. At this point, you can begin on your homework.